So the only piece we have left from chapter 5 is that there's a special formula for the mean and the variance of a binomial random variable. Earlier in the notes, we had this formula here, which will give us the mean for any random variable. And then we have a probability formula for our binomial probabilities. So if we plug this probability right here, if we plug this into this formula in here, then we end up with this. And it's a lot of messy math to go through that I'm not going to bore you with, but you can show that this whole summation will always just turn out to be n times p, which is a tremendous shortcut. So in our example where we were flipping a coin 3 times, so n was 3 and our probability of success was 0.4. You multiply n times p, 3 times 0.4, and you get 1.2 for the mean. So this is a tremendous shortcut compared to what we had to do if we did not know it was binomial. If we did not know it was binomial, we would do each value of the random variable, 0, 1, 2, and 3, times their respective probabilities to get that mean of 1.2. But if you know it's binomial, that means you should know the number of trials and the probability of success. You just multiply the number of trials times the probability of success, and you get the mean. But again, this shortcut only works if we know it's a binomial random variable. Similarly, if we plug our probability formula for binomial, if we plug that right in here in the variance formula, so that the variance formula now looks like this, again, it's very messy to prove this mathematically, but it can be shown that this whole summation just comes out to be n times p times 1 minus p. Again, that's a tremendous shortcut for finding the variance. In our example, n was 3, the probability of success was 0.4, and then 1 minus the probability of success. You multiply those three numbers together and you get 0.72, and that's exactly the same 0.72 that we got from doing this ugly formula before. But again, earlier in these notes, we didn't realize that this example was binomial, so we had to use this long formula, one of these two formulas for finding variance. But if you know that the random variable is binomial, then all you have to do is n times p times 1 minus p. So just to recap what we know about binomial, this is the formula for the probability distribution function. Not really a big deal that you have that formula memorized, because remember, you can use a calculator that has the formula already built in, or you can use the table that already has the probabilities calculated. We have this formula for the mean. Remember, the mean is also referred to as the expected value, so be on the lookout for a problem that might say, how many successes do we expect? That's a tip-off that they want the mean. And we have this formula for variance, n times p times 1 minus p. And then if you wrap that up in a square root sign, it's the formula for standard deviation of a binomial. So we have those shortcuts for binomial. Okay, that's about it for chapter 5. Good luck with the homework.